Hello everyone. In this tutorial, we'll see about microservices and what is the use of microservices. And already we have a monolithic type of system. So why we need to go for the microservices? So if you see here, currently most of the projects we use like monolithic architecture. It's like single project which is having the user interface, business layer, data interface, and the database. So this is how the MVC architecture works, like in monolithic. And so it's a single application, and when you deploy it, we will deploy the whole application into the server, right? But when it comes to microservices architecture, it's a combination of multiple microservices. Like we will divide our big monolithic application into multiple microservices, and each and every microservices can be developed in different languages. Like one can be developed with Java, one can develop with Python, another can be developed with Node.js, like that. So this type of architecture helps us to interact with different type of microservices, and we can write our code in whichever language you want. So that type of feasibility can be given with the help of microservices architecture. And we'll see in more detail what is the use of microservices architecture with these different operations. Like I have divided into 5 different operations. Let's say like development, testing, deployment, scalability, and fault tolerance. So let's say when you have a monolithic application. So what is that? So it's a big application, and the development will be very much complex. Means it have large number of lines of code and large number of modules can be there in a single entity, in the single folder. And when you want to do any code changes, right? So you have to, it will become very complex. But when it comes to the microservices, it's like it will divide in that big application into different small modules, like each and independent modules, and which makes the developments very fast. And when it comes to testing, if you want to test a small line of code which you have fixed in the big application, you need to test the whole application, which makes more complex, right? But when it comes to the microservices, like that application we have divided into multiple microservices, like 50 to 100 microservices. You will test only one particular microservice where you fix the code, right? And which makes the testing very easy because it's an independent module. And also deployment. So deploying a large application will be very much complex and error prone and also time consuming, right? When it comes to the microservices, you will be deploying each and every individual module, and which makes very easy for the deployment. And when it comes to the scalability, even the microservices having an edge when it comes to scalability, because we can have individual modules, and which increases the scalability of it. And when it comes to the fault tolerance, the application is fails within the monolithic, because whenever the application down, the entire system will get down. But when it going with the microservice architecture, the entire system will not get down because it's a single microservice which comes down. Then the fault tolerance functionality, which makes that again that application rerun and starts working, so that whole application will not get down. It's only the single microservice which will not work, and automatically it will get healed with some techniques or with some technologies that we use in the microservices, right? So coming next slide, we'll see in more detail what is the architecture of microservice and everything in the next video. Thank you. As I do the microservices architecture. So as we in previous tutorial we have discussed about what is the difference between monolithic and microservice, what is the advantage of microservices, right? So because it gives some extra advantage with some operations that I have said, like fault tolerance and scalability and deployment, testing and development. So we'll see in more detail in this architecture. Like the microservices architecture will have like multiple applications interacting to each and every service, where the API gateway has the initial point where the authentication or authorization of this all these applications will be happened in the API gateway, and API gateway will be doing that, and then API gateway will be redirecting that each and every request, which will identify the each and every service to which service I need to redirect this request coming from the application 1 or application 2 or application 3. So that can be done by using a service registry. So what is this service registry? So each and every microservice and API gateway, all these will get registered into the service registry. And once any request comes from the application gateway, what it will do is it will go to the service registry and it will check whatever services we have. and what exactly the application or the client is requesting to redirect to which service. So it will identify everything in the service registry, right? And then it will redirect to the specific each and every microservice. And let's say if any microservice get down, so we have discussed the fault tolerance, right? So if any microservice comes down, so the fault tolerance can be implemented by using Histrix. So Histrix is a service which was developed by the Netflix one. So we are using that Histrix here. So it will identify, and the fallback methods will be done on the particular service which got down, right? So that's how the fault tolerance makes microservices architecture very much important. And then we'll see about what is a Zipkin server. So Zipkin server is nothing but the traceability. It's like we have multiple microservices, like hundreds of microservices in an application, and all those microservices related logs and everything, from which microservices it is going to which microservice. Let's say microservice one is interacting with the microservice 3, microservice 1 is interacting with microservice 10. So how is that traceability is happening, and what are the logs, right? Everything can be done by using a Zipkin traceability server. Okay. And then if suppose we have a common properties, so we can't copy the same common properties into each and every microservice. Suppose next day the client requirement got changed, and he asked us to modify some of the property files. Then again you need to modify all the property files in all the 100 microservices. Instead of that, we'll have a common location where we'll keep our property file or common data, so that we can every time we can call that common data into our microservice. So that common data where we'll place is in the config server. Okay. So this config server will be interacting with each and every microservice, and this config server will be having the property file in the GitHub. Okay, so from GitHub we'll take the data from by using config server, and from config server we can inject each and every property file into the each and every microservices. So this is how the common microservices architecture will be there, and in coming tutorials we'll see like how each and everything will be developed, and each and everything will be each and everything will be linked, so that we'll see a smooth and seamless application deployments and application connecting, right? So thank you for now, and we'll come up with another video with how we can create a microservice, different microservices by using the Spring Boot application, right? Thank you for that. Welcome back again. So in previous tutorial, we have seen the importance of the microservice architecture in detail, all these API gateways, Histrix dashboard, and Zipkin servers, config servers, and service registries and everything, which makes a microservices different from the monolithic architecture, where monolithic architecture has single type of architecture, where single application will be deployed every time into the server, where here in the microservices it will which are the impacted microservices only will be deployed into the server. That makes the life easy for the program developer, right? So now we'll create a Spring Boot application. So for creating a Spring Boot application, we can go to this site like Start Spring IO. There we can create which project you want to download. Let's say we have creating a Maven project, and I'm creating here Spring Boot 1 as an example, and we are selecting Java version 17, and here we need to add the dependencies. Like I added Spring Web, Lombok, and Spring Boot DevTools. So if you want to add another dependency like database or JPA related, so you can select that. So you can see here JPA got added into the dependencies, and now we'll click on generate. So it will generate a zip file, right? It will generate a zip file. So just go to the downloads folder. This is a project we have downloaded it, and just extract it so that you can open that particular downloaded project, Spring Boot project, into the STS, Spring Tool Suite. So I'm using Spring Tool Suite for this microservices tutorial related. So just click on the import projects and click on the existing Maven projects, and then select the project where you have downloaded it, right? So the Spring Boot demo one, and you can see the form.xml is already created. Okay, just expand it, and you can go to the pom.xml and just see which version of Spring Boot you have selected, the Java version, and the dependencies, whatever we have selected it, everything comes auto-generated, and we can see the package structures and everything, and we can see the Spring Boot project with annotated with @Spring Boot application, and we can see application of property file. Now it is empty, so we need to add some data into it. So this is one way of creating a Spring Boot project. There is another way of creating a Spring Boot project from STS itself. So how we can do that? Just go to the file and click on new. So you can see Spring Starter project. So just click on Spring Starter project. So again, it gets that service URL same start.spring.io. And now I create another project like Spring Demo 1, Spring Boot 2, and I will select which type of project I want, Gradle or Maven. I will select the Maven, and I'll give example 2 so that it will not get redundant. And you can see I've given the artifact and group ID, and next click on next for the dependencies adding. So I can add the dependencies like which dependencies I want into this project, and like that. You can select the which Spring Boot version you want. I'm going this version and just click on finish. So once it is done, you can see demo 1 Spring Boot project. It's created. Right? You can open again the same type of folder structure will be there, which you can do it in the either of the ways from the that link or from the browser link or from the Eclipse or the STS, we can say. You can see the same project created, demo 1 Spring Boot application, annotated with @Spring Boot application, and you can see the pom.xml created with all the dependencies, whatever you have selected, right? This is how we create Spring Boot projects. So right now I have created 2 Spring Boot projects. So I will add some more code like service layer and repository layer and controller, and then we'll see next video, coming video, how these two services interact with each other. Right? This is how the microservices works, like interacting one service with another service. Right? So we will see in next tutorial how these two services interact with that, and after that we'll create a API gateway and service registries and all this. So config server even. So we'll see how all this will work into the microservices environment.